This is AP problem number 2. Sodium benzoate is a salt of the weak acid benzoic acid. A 0.10 molar solution of sodium benzoate has a pH of 8.60 at room temperature. So first off, we're going to find the complete equation for the reaction equilibrium, which is right here. And then go to question number, letter A. Calculate the concentration of hydroxide in the sodium benzoate solution described. Okay, the first step right here is going to find the POH, because we're given the pH, but since we have hydroxide, we need to find the POH. So we're going to do 14 minus 8.6 equals 5.4, so that's the POH. And then step 2, we're going to change the log, or how we normally find the POH. We're going to change that into exponential form, which is going to turn into the base of 10 to the power of negative 5.4, and that's going to give you 3.98 times 10 to the negative 6. We have 2 sig figs, however, so that's going to turn into 4.0 times 10 to the negative 6th. Alright, letter B. Calculate the value for the equilibrium constant for the reaction, given right there. So first off, we found our equilibrium equation. K equals concentration of hydroxide times C6H5COOH over concentration of C6H5COO minus. And so we know the number for the hydroxide, and since it's a 1-to-1 ratio with the C6H5COOH, it's going to be 4.0 times 10 to the negative 6 times 4.0 times 10 to the negative 6 over 0.10, which is going to equal 1.6 times 10 to the negative 10. That's going to be your KB value right there. And that's your answer right there. Okay. Letter number C. Calculate the value of K, the Ka, the acid dissociation constant for benzoic acid. So since we know that Kw is equal to 1 times 10 to the negative 14th, to find Ka, we're going to have to divide by Kb, because Ka times Kb equals Kw. So right here, Kw divided by Kb, which is right here, 1 times 10 to the negative 14th, divided by 1.6 times 10 to the negative 10. It's going to get you 6.25 times 10 to the negative 5. So the Ka is 6.25 times 10 to the negative 5. And then part D, a saturated solution of benzoic acid is prepared by adding excess solid benzoic acid to pure water at room temperature. Since this saturated solution has a pH of 2.88, calculate the original concentration of this benzoic acid solution. So right here we have the Ka equation, and we're given the pH, so what we're going to do right here is the hydrogen ions. We know that's going to be equal to 10 or up to the negative 2.88, because that was the pH given. We're just changing the log into exponential. That's going to give you 6.3 times 10 to the negative 8. You're going to set that equal to your regular equation, your equilibrium equation, which is going to be 0.0013 times 0.0013 divided by x, and then x is going to equal 0.028 molar. And that is the last one.